W2 be the subspaces of the 4-dimensional vector space R, that is defined as this 2, and we need to find the basis and dimension of W1, W2, their intersection and the sum of the subspaces, right? So first let's find out the basis and dimension for W1. So W1 is defined as this: all those vectors A, B, C, D of the format such that B minus 2C plus D is equal to 0, where A, B, C, D are belonging to the set of real numbers. So we are having this condition. Let's write this: B minus 2C plus D is equal to 0. Let's mark this as 1. Now since 1 is a system of one linear equation in 4 variables, these are 4 variables. So the number of free variables is equal to the number of variables minus the number of linear equations, and we are having only 1. So this is 3. So we can choose 3 free variables. So always try to choose first that variable to be the free variable whose coefficient is not equal to 1. So I am choosing C, and in sequence I am taking A, B. So these 3 are the variables which I have chosen to be the free variables. Now I need to give them some value so that I can get the value of D. So if you are having 3 free variables, just write the format of identity matrix. So it is 1, 0, 0, 0, 1, 0 and 0, 0, 1. That means A is taking value 1, then B is taking value 0, then C is taking value 0 first. So for A equal to 1, B equal to 0, C equal to 0. C is 0 and B is 0. So we are getting D to be as 0. So for A 1, B 0, C 0, we have D 0. Then A is taking value now 0, B 1 and C 0. So for these values, the values of D is, now here B is 1 and C is 0. So D is taking the value 1. So D is 1. In the last set, we are having A 0, B 0 and C 1. B is 0 and C is 1. So now D is taking the value 2, right? So now let's write the basis. From the first set we are having the basis. Please write the format as A, B, C, D, right? So first element is 1, 0, 0, 0. Second element is 0, 1, 0, negative 1. Third element is 0, 0, 1, 2. So these are the bases for W1, and the dimension of W1, the number of elements present in the basis, that is 3. So it is 3. Now W2 is defined as this. Now let's find out the basis for W2. W2 is defined as this: all those vectors A, B, C, D such that A equal to D and B equal to 2C. I can write this as again A, B, C, D such that A minus D is equal to 0 and B minus 2C is equal to 0, where A, B, C, D is belonging to the set of real numbers. So I am having these two conditions. Let's write this: A minus D equal to 0 and B minus 2C equal to 0. Marking this as 2, since 2 is a system of 2 linear equations in 4 variables. So the number of free variables equal to the number of variables minus the number of linear equations, that is 2. So this is equal to 2. So we need to choose 2 free variables now. First, we take the variable whose coefficient is not equal to 1. So I am taking free variable to be C. From this equation I have chosen C. Now we don't have to choose B. From the first equation, let's choose any of A or D. So let me choose A. Giving these the values, so write down the identity matrix 1, 0, 0, 1. So on the basis of these values, A is taking 1, C is taking 0, we can find the value of B and D, right? So if A equal to 1 and C equal to 0, from the second equation, if I take C equal to 0, I get the value of B to be 0. And from the first equation, A is 1, so D is equal to 1. So it is 0 and 1. So for A 1, C 0, B equal to 0 and D equal to 1. The second set, A is now 0 and C is 1. For these values, the values of B and D are A 0 implies D 0. C equal to 1 implies B equal to 2. So B is 2 and D is 0. So write down the bases now. Again, the format A, B, C, D. So the first element is 1, 0, 0, 1. Are you getting that? First we write the value of A, then B, then C, then D, right? Okay, the second element from this set, it becomes 0, 2, 1, 0. So these are the two elements in the basis. So these are the bases for W2, and the dimension of W2 is the number of elements, that is 2. Now we need to find out the dimension of the intersection of the subspaces. Since we are having W1 and W2, these two subspaces, that is defined as these. So the intersection of the subspaces will be defined as all those vectors of the kind A, B, C, D such that B minus 2C plus D equal to 0, writing this condition and also these two conditions. A equal to D and B equal to 2C, such that where A, B, C, D belongs to the set of real numbers, this is important to write. So let's write all these three equations. Since 3 is a system of 3 linear equations in 4 variables. So number of free variables is equal to the number of variables minus the number of linear equations, that is 3. So that is equal to 1. So we need to choose only one free variable from these three equations. And always choose the variable to be the free variable whose coefficient is not equal to 1. So I am choosing C. Now we need to give the value to C so that we can find the value of A, B and D. Whenever you are having one free variable, just give value as 1. From the third equation we get for C equal to 1, B equal to 2. From the first equation, B is 2 and C is 1. So D equal to 0. And from the second equation, if D is 0, A is 0. Right? So for C equal to 1, we get the value of B to be D as 0 and A as 0. So writing the basis, again the format A, B, C, D, right? So writing the value of A 0, then the value of B, then the value of C, then the value of D. So this is the basis for the intersection of the subspaces having only one element. So the dimension is 1. Now to find the dimension of the sum of the subspaces, and we are having the formula for that. That is dimension of W1 plus dimension of W2 minus the dimension of their intersection. And we have found in the previous parts the dimension of W1 as 3 plus the dimension of W2 is 2 minus their intersection. Just now we have found 1. So this is 5 minus 1, 4. So the dimension of the sum of the subspaces is 4. Alright, thank you.